And then we come to the last couple problems, so number 7. So now we're on the complex numbers, and then eventually other abstract number systems. And so here we want to subtract two complex numbers. So it's relatively simple. We have 1 plus 2i, so we just copy that down. And then remember to distribute that minus sign through. So it's minus 1, and minus a minus is a plus, so plus 2i. So this is equal to, the 1's are going to cancel. 1 plus negative 1 is 0. And then 2i plus 2i is 4i. Right? $2 plus $2 is $4. Down here it's a little bit harder because you have to multiply this out. And so the idea is you multiply 3 times 2 and get 6. And then you multiply 3 times negative 3i and get minus 9i. And then 5i times 2, that's plus 10i, because 5 times 2 is 10. And then 5i times a negative 3i is minus 15i squared. And so you have to remember then, I is actually equal to the square root of minus 1. And so eventually we'll use this that I squared is equal to negative 1. So this is equal to 6 minus 9i plus 10i's gives me 1i. Right? Minus $9 add $10 is $1. And then minus 15. And here's why you use this I squared as negative 1. Right? So this is times negative 1. And so that's equal to 6 plus I minus 15 times negative 1 is plus 15. And so I get this to be equal to 21 plus I for my answer. And the final problem we're going to do here, I have 2 more problems. Okay, so number 8 is do the following operations using clock arithmetic. So again, these are more abstract number systems, and the idea is I have a clock over here. So I have 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And I can do arithmetic on this clock. So I can take 6 and minus 10. So I start at 6. Because I take minus 10, I'm subtracting 10, I don't go this way, I go counterclockwise. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is equal to an 8. And then the next one, I have 8 plus 9 minus 2, so order of operations. It doesn't really matter which one I do first, so I'll start with the plus. So 8 plus 9, so I start at 8, and I add 9. Now I go, since I'm adding, I go clockwise. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that gets me to 5, and then I subtract 2. 1, 2. So it's equal to 3. And so it's pretty straightforward. And then finally, working with functions and doing these following operations. So f of x minus g of x. So you just copy it down. F of x is a function x squared minus x minus 3. And then I'm going to take away at x plus 2. Make sure you put parentheses around x plus 2 because you're taking away the quantity. And so this is equal to x squared minus x minus 3 minus an x, right? And then minus a plus 2 is a minus 2. And so that's equal to x squared minus x, right? Combine like terms, you get minus 2x. Minus 3 minus 2 is a minus 5. On part B, we want to multiply the two functions. And so f of x times g of x is equal to, and we can just copy down what the functions are. So x squared minus x minus a 3, and then times an x plus 2. Alright, so we can take x squared times x and x squared times 2, and so this will be equal to an x cubed plus a 2x squared. Alright, then we take the negative x and we're going to multiply it by x, and then we'll take negative x and we'll multiply it by 2, so we get minus x squared, right, for negative x times x, and then minus a 2x for negative x times 2. And then finally, we take the negative 3 times x and then a negative 3 times 2. So negative 3 times x is a minus 3x, and a minus 3 times a 2 is a minus 6. And then we combine together like terms. Right? So this is equal to an x cubed. There's only one x cubed term. There's 2x squared terms, so you have a 2x squared minus an x squared, so you're just left with 1x squared. you have a minus 2x and minus a 3x, you get minus 5x, and then finally you have a negative 6.